Hello, this is TLV with 100,000 diamonds plus and a new episode of Computer Craft coding Arcane Frame Quarry here. And I decided before I want to do the Y move here, I'm gonna make it so it makes a little more sense what all these variables are here. So I'm gonna make the coordinates for this program all user input first. Let's put it after this function here, end. So I made it look a little bigger by just spamming out Y's there, so I can more easily find it. And if you test the code, save it and run it, and it gives an error, it will always tell you which line, or almost always tell you which line the error is at, so you can easily correct it. So that's very comfortable compared to other compilers. Fourth, red power 2 here. So let's do the coordinates here. Get coordinates. I'm gonna put this at the end here so we can see here. So I showed you before in the first episode that prints something, right? Print. But we can write to the terminal here, and the printer gives a character return when it's done. So you can't do anything about that. This will do a character return when it has executed this line of code here. We'll enter the next home. But for our user inputs, we don't just want to continue to write. So let's check on the x distance, y distance, x temp, y temp. We don't have to worry about, but x dir, y dir. So let's see. Let's start with the depth here. Just call it term.write. So this is the same as print, but without the character return. Depth 0 or 600, and a colon, please. There we go. So now it will wait for the user input here. And now we do the user input. So now it writes that line. And we will just want to do, let's see here, read. Depth equals read. Where's equals? There. Read. So this is what we have to make our, in fourth, for example, in red power 2, this read, this command here, it takes user input from the console here and puts it into the read variable. But in fourth, we had to make this read program ourselves so it understood. So that's pretty funny. But here we can just read the depth. But what you have to be careful about is that read always reads a string. So depth will be, this will be text now. Even though I read, I enter 1, for example, or 2, it will not be the integral 1 or 2. It will be text, defined as a string or text. So what we want to do here is to number read, and read inside to number. So whatever we read, it goes into to number here for the depth. Alright, so it's gonna be a number. 0 or 600. So now we have actually defined depth here in the coordinates. So let's go to the digger again. Get digger. I said sleep here. Now we can actually do depth here. We can call for depth. Because the coordinates will execute the first thing in the program. Even though I put it down here, it doesn't matter where I put this function, because this is not inside the program yet, it's just a function, which I forgot to write here, of course. So that's good to know. Function. I have to end it. So let's see, what do we check next? Maybe we want term.write, want blah blah blah. X direction maybe. direction X maybe. Direction X. Perfect. Now we're gonna read something. Let's call it X deer, right? X direction should be equal to read, just read, because we want a string here. So that's how simple it is, to read a string or to read a number. And now we want term.write distance X. Change song, sorry. And we want X distance here. So now all the... what the fuck? So all these variables will have some value or strings now. So we don't have to care about in the beginning here what I wrote there. So X distance will be let's see, true number again. Number, read, and two parentheses there to finish the to number. And I want to do the same with term.write and I can actually write it here. Let's see what we want. We want direction Y. One space here, so it starts one space from the semicolon or from the colon. And we want Y there to be read. And then we want the X distance, Y distance. See. No. Yeah, we want that, but above that we want another right again. Term right. Distance. It's Y. Let's see if this will make sense. And I'm gonna do some nifty thing at the bottom of this function here. To number, read. So read the input from the user again. Okay, and now we read all the variables here that we need. I think. So now we're gonna define a new variable. Let's call it xy. So this will minimize the amount of code very much. So we want to combine. Let's see here, I'm showing with the mouse again. We want to combine these movements. Whoa. I'm gonna show you. When we do a user input in this program, we will go into xMove, right? This L right, but we will combine them with these L right. So there can only be 8 different options here, because moving left in X direction, you can't move left in Y direction. If you move, I'll show you here. If you move left in X direction, you can only move upwards or downwards in Y direction. So you can't move left or right, because then the query won't make any sense. So it's not going to be in that many different ways to run this. It's only going to be 8 ways. So to the left, we've got 2 ways. Up, 2 ways. Left and right. To the right, up and down. Down, left and right. So we want to combine this. Like, for example, in the xMove here, we take left and combine it with maybe forward here. Left, forward. So it will left. Okay, stick with me here. It runs, digs to the left and then forward. But the program will execute it like this, like my mouse here. Left, going up a little, dig, right, dig, like this. until maybe it has dug like 100 by 100 or whatever, how big you want it. So that we can call that left from X and forward from Y. So we want to combine them. So let's take the X direction. This dot dot will combine two strings or put them next to each other with Y direction. So this will, if I write, so this is the nifty part here. So if I read in the X direction, I read L. In the Y direction, I read F. Now we will, in the XY, we will store LF. Very cool. So that's what we will execute later. So in the end of this code here, and end of coordinates. That's very cool. Let's edit it up here as well, so we can see. These values will be changed later anyway, so it doesn't matter. X there, dot dot, Y there. Just call it XY. That should be fine. And then we go back into YMove here and do the first direction for YMove. It's gonna look very similar to xMove, but without the digger. We're not gonna dig in the Y direction, right? Let's check here again. The X, it starts with digging down, and then dig, and then dig, and dig. And then this is from above again, and then it goes into the new position here. So we don't need the Y movement to dig. So it has dug holes all over. Here's a hole, here's a hole, here's a hole, here's a... I'll write it again instead. So here's a hole, hole, and then it moves upwards here. So this is the Y. It has moved into this position here, but we don't want to dig again because then it will dig twice. So let's do the X movement has all the digging. Then the X movement starts to dig again. Dig. Dig. Dig, like that. Alright? And it goes to the left here. And it goes up with the Y. There's not a hole here. And then it starts the digging again. Like this. Like so. So let's delete this shit here. So we got all the coordinates here that we need. But we haven't... So we can call for them here. Coordinates. So now we can define the coordinates at least when the program starts. So this is what all the program does at the moment. But we have done a lot of functions already. So let's get up here. This is movement X. Call for movement Y just below it. End of movement Y. Very good. So we don't need to reset the Y temp here. Since the Y temp is not going to be reset. Look here, we need to reset the X temp every time, right? Every time we go into the X movement for a new go here, we move to 60 blocks, and the distance criteria is met here. And then we move upwards, then we want the X temp to be 0 again, and we move 60, otherwise it will just go on forever. So we have, every time we call for this X move, we want the X temp to be reset to 10. But that's not what we want for Y temp. So the Y temp will start at 10 in the program. Because the Y movement will only run once, I think. Function Y move. Or will not run once, but the Y temporary will only count upwards one time. Once it has counted all the way to the Y distance, then the whole program is complete. So let's see what we want here. So we want if. Same here, check for the direction. If Y direction equals to left. I'll do the forward part first here, because that can be connected with left. So let's do the forward. What do we want? First then here. Then we go into the if this criteria met, then we want a for loop. I'm gonna move the quarry upwards 10 times, or forward, whatever we call it. For I equals 0. No, 10 equals 1 to 10. 10 times. So we want to do similar to the other one. Set bundled output. Back in lowercase. Colors, I think it's light blue, so let's check that. We're on line 60 now, as you can see down here. Save. So forward, what did I write here? Left, right magenta, forward light blue. Very good. Yellow back. And we're gonna use some others later. Edit AQ. We're inside. Let's go back to line 60 like I just said here. And we wanna do it like before, I think. Sleep for 3. And we wanna, just to be sure, which is not needed again, because once you change the color, it will reset the old color. So if I change from light blue to another color, it will reset the light blue back to turn it off again. But I just want to make sure that nothing happens. Sleep for maybe 0.5. Alright. Okay, what do we want more? Now we want to increment the Y temp, just like we did with the X temp here. Y temp plus 1. And we want to check if the Y temp equals the Y distance as well. Equals the Y distance. Then we just want to return true. We don't want to reset it. Else, nothing here. So this program is actually a little bit smaller. And we're gonna have else if here, right? And else if and end. Else if, for example, equals Y direction equals back. So that's the Y direction, I think. So we're almost done. almost. Not really, but I'm gonna do else if Y direction. I want to have them in the same order as the input here, so it's easier to find where you are in the code. So I want to start with the condition estimate, then for L, then R, then right, then forward, and the last one backwards. So this is the Y move. And I will write one more of these guys next time. Maybe the left one, just to repeat myself. And very quickly, and then we will go into the next one to combine this. And we can call this function. Oop, here's the end of the movement Y. We'll call this the combine of X and Y movement. So let's call it quarry move. Function quarry move. And we'll see. So we'll see what we are gonna put in here. So we're gonna use what I defined here before, the XY. We're gonna take advantage of this this system I created for the XY down here, and it's gonna make the program much smaller. And so see you guys in the next episode where we continue with the quarry move and see what that does. I have to end the function here. Make some space. Make a comment here. Quarry move. Meant. Alright. So see you guys in the next episode where we will continue this shit. Bye bye.